Welcome to Wire and Cable Fundamentals. In this session, we'll define essential electrical performance terms: ampacity, voltage drop, impedance, capacitance, and inductance. You'll learn the definitions, their importance, and see real-world examples. Let's get started. Selecting the right wire or cable goes beyond just gauge and jacket. It's about how the conductor performs electrically under load. These 5 terms define the performance envelope of any cable run, impacting safety, code compliance, equipment lifespan, and signal integrity. Ampacity determines thermal safety. Exceed it, and insulation silently degrades until failure. Voltage drop and impedance reduce system efficiency, causing equipment like motors to run hot and controls to malfunction. Capacitance and inductance are crucial for signal integrity, especially in instrumentation, data, and audio applications. Ampacity is the maximum continuous current a conductor can safely carry without exceeding its temperature rating. It depends on conductor size, insulation type, ambient temperature, and installation method. Governed by NEC Table 310. 15. B. Ampacity must be derated for factors like conduit fill and high ambient temperatures. Undersized conductors near or above ampacity lead to insulation failure. For example, a 40-amp motor feeder with 8 AWG THN in a 50 degrees Celsius boiler room must be derated, reducing its effective capacity. Proper design might require upsizing to maintain safety. Voltage drop is the reduction in voltage across a conductor due to resistance, increasing with length, smaller size, and higher current. NEC guidelines recommend no more than 3% voltage drop for branch circuits, or 5% total. A 5% drop on a 120-volt circuit only delivers 114V to the load, which can cause equipment issues. In a real-world example, a 300-foot run for a CNC machine shows how voltage drop and ampacity can quickly become limiting factors, especially as loads increase. Upsizing conductors solves both voltage and ampacity problems. Impedance, measured in ohms, is the total opposition to AC current, combining resistance, inductive reactance, and capacitive reactance. Unlike DC resistance, impedance is frequency-dependent, affecting both power and signal cables. For 60 Hz power, impedance is nearly the same as resistance. At higher frequencies, impedance mismatch can cause signal reflections and loss. For example, VFD output cables at high frequencies can create voltage reflections that damage motor insulation. The solution: use VFD-rated shielded cables or load reactors. Capacitance is a cable's ability to store electrical charge between conductors or between a conductor and its shield. Measured in picofarads per foot, it's determined by spacing, insulation thickness, and the dielectric constant of the material. High capacitance limits signal bandwidth and slows response, which is critical in instrumentation and data cables. For example, a 1,200-foot 4 to 20 milliamperes loop with standard cable can experience signal lag. Specifying low-capacitance shielded cable with special dielectrics helps maintain fast response over long runs. Inductance is a conductor's property to oppose changes in current by generating a magnetic field. It's measured in microhenries per foot and is affected by conductor spacing, size, and arrangement. Inductance causes voltage to lag current, affecting power factor and cable performance at AC frequencies. In VFD motor leads, cable inductance interacts with drive switching, sometimes amplifying voltage spikes. Adding a load-side reactor can increase inductance and protect motor windings from excessive voltage rise. Here's a quick reference for all 5 terms. Ampacity is the maximum current before insulation overheats. Always derate for conduit fill, temperature, and bundling. Voltage drop is the voltage lost across the conductor, directly affecting motors, controls, and lighting. Impedance is the total AC opposition and must be matched at signal frequencies. Capacitance is charge storage, with high values degrading long data or instrumentation runs. Inductance opposes changing current and can amplify VFD voltage spikes. Consult NEC codes and manufacturer datasheets for proper specifications. To summarize, ampacity sets the thermal ceiling. Always derate for installation conditions. Voltage drop above 3% starves equipment. Upsize conductors for long runs. Impedance is frequency dependent. Mismatches cause signal reflections. Capacitance limits signal bandwidth. Specify low capacitance cable for long instrumentation loops. Inductance opposes changing current. Manage motor cable inductance with shielded cable or load reactors. Always review these parameters on cable datasheets before specifying a critical run. Understanding these terms helps you spec cable like a pro.